in this lecture we are going to see basic refractories. The basic refractories which are very stable to basic materials, but it can easily attacked by acidic materials. So the basic refractories are only used in where we can use the basic materials or where we can use the materials which are having basic in nature. So in this type we are going to see two types of bricks. One is a magnesite bricks and another one is a dolomite bricks. So first, the magnesite bricks are mostly used in basic furnace because it has in a basic, it comes under basic refractories and its basic nature. Because magnesia is a basic nature. So how we can going to prepare this magnesite bricks means we have to use the calcined magnesite, that means the calcined means the magnesia MgO is take from ore, purify it, that means screened. After that we have to calcine at above 400 degrees Celsius and it is powdered to a proper size, and then we have to mix it with caustic magnesia or sulfite lye. The sulfite lye is obtained from paper industries. It is a waste of paper industries. So we have to mix the magnesite materials, that means calcined magnesite materials, first grinded to proper size and then mixed with magnesia and sulfite lye or otherwise Fe2O3 iron oxide as a binding material. After that, after mixing and molding, we have heated that magnesite bricks up to 1500 degrees Celsius slowly for 8. Then after that we have to maintain that 1500 degrees Celsius up to 8 hours. After the 8 hours we have to cool slowly to get a perfect structure or perfect crystalline nature of magnesite bricks. Next we are moving to the properties of magnesite bricks. Exactly, the refractoriness of magnesite bricks are up to 2000 degrees Celsius, and then when we are applying load, the refractoriness under load is decreased to 1500 degrees Celsius. So we have to check up that RUL when we are applying magnesite bricks on furnaces or otherwise some construction purposes. After that, it has a good crushing strength, and then it has good resistance to the basic slags because of its basic in nature, and it has a very little shrinkage. That means when we are heating, the shrinkage of magnesite bricks are very less, so the expansion and compression, that means contraction of magnesite bricks are very less, so we can use it for high temperature and also when increasing the sudden temperature. But the disadvantage of using magnesite bricks are it has a lot of spalling and also poor resistance to the abrasion and tendency to combine with water and carbon dioxide. That means it is chemically active. So we before using the magnesite bricks we have to check the chemical reaction or otherwise where we are going to use that magnesite bricks. If we are using some metal refractory furnaces, that means metal making furnaces or otherwise if that processing can evolve carbon dioxide or it releases high water molecule means, then we can't use this magnesite bricks to that area. So we have to check before applying this magnesite bricks for construction purpose. And then next we are moving to uses of magnesite bricks. The magnesite bricks are generally used in steel industry for the lining of basic converters, because steel industry has both furnaces, one is an acid converter and another one is a basic converter. If we are using the magnesite bricks in acid converter means, then there will be a reaction occurs, so it can easily get corroded. So in this regard we are using the magnesite bricks for the lining of basic converters and open hearth furnaces and also hot mixer linings, because it has a good resistance, very little shrinkage, and also copper converters, and then reverberatory furnace for melting of metal, lead, copper and antimony ores. And then we are using the magnesite bricks in hot zones or cement rotary kilns, and also it can be used in refining furnace for the gold, silver and platinum, etc. That means when we are using some cost effective material, that means cost wise material, costly materials means there we need to refine that material for purification. So in that furnaces we are using magnesite bricks. Next one is an dolomite bricks. So the dolomite bricks is the mixture of calcium oxide and magnesium oxide, and we can take equimolar proportion for making dolomite brick. After that we have to that calcium oxide and magnesium oxide is mixed with silica binder. Then we have to fire at 1500 degrees Celsius about 24 hours. So if we are firing it below 24 hours means then the stability of that dolomite bricks are lesser. So the firing temperature is very important in the case of dolomite bricks. And next we are moving to the properties of dolomite bricks. The dolomite bricks possess less strength, because the strength, that means it has a low RUL and it has a more softness and porosity. If softness is higher means then RUL is lower. So in this regard we can correlate it, and also we have to check the porosity also. If a good refractory must have a less porosity, but in terms of insulating or conducting refractories means then there the high level of porosity is accepted, but we need to check where we are going to use this dolomite bricks. So in this regard it has a low porosity, and also it has a greater sinkage and higher hygroscopicity. That means it can react with water and carbon dioxide. So hygroscopicity means it is chemically active, like has like magnesite bricks. And then the RUL of dolomite, that means strength of dolomite bricks is 1650 degrees Celsius when we are applying the weight of 3.5 kilogram per centimeter square. So okay, we need to stop this reduce the hygroscopicity of dolomite means then we can mix it with serpentine, that means magnesium oxide and silicon dioxide. After that we have to calcine at above 400 degrees Celsius in absence of air. There we have to get di and tricalcium silicates. This di and tricalcium silicates do not absorb water and carbon dioxide. So if we want to convert dolomite as a less hygroscopicity means we have to mix it with serpentine, and also when we are calcine with that serpentine mixture and also dolomite mixture above 400 degrees Celsius means it forms a di and trisilicates. So there the tri and disilicate calcium silicates do not absorb water. So where we are using this dolomite bricks means it is rarely used as a direct refractory because of its softness and also greater sinkage, but we can use it as a repairing materials. And also the dolomite bricks are used in basic electric furnace linings and Bessemer converters ladle linings. Next we are see neutral refractories. The neutral refractories are either weakly acidic and also it contains weakly basic in nature. Generally it is not affected by acid or basic materials, that means weak acidic and basic materials, but based on the composition of that material or composition of basic materials we have to classify either it can attack by strong acid or base. So in this we are going to see carbon bricks and also chromite bricks and phosphorite bricks. The carbon bricks are how to manufactured with how to manufacturing means the crushed coke is mixed with pitch or tar, that means as a binding material, or graphite, then it is mixed with clay and then heating about 1300 to 1400 degrees Celsius. That means first we have to take an coke and we have to mix it with pitch or tar, then graphite and then clay, and then we have to fire it 1300 to 1400 degrees Celsius. During firing, the contact of bricks with air is minimized by filling the space between the bricks with the mixture of sand and powdered coke, because we have to, if we have a carbon brick basic materials here and then if the air is present in outside means we have to prevent the contact between air and carbon bricks by sand or powdered coke, because when we are exposing this carbonaceous materials into air means it easily get oxidized. So we have to prevent this to get high porous in nature of carbon bricks. So next we are moving to the properties of carbon bricks. It has an excellent refractory material only, but it can only used under neutral or reducing conditions. Why? Because if we are using it in oxidized condition or open air condition or in exposed in acid means it is easily get oxidized due to the high reactive nature of carbonaceous materials present in a carbon bricks. Next one is it is a practically infusible and insensitive to spalling, and it has a highly thermal conductivity due to the structural morphology of carbon bricks. And next one is it has a closed structure and it can withstand temperature fluctuations and chemical attacks, but only in reducing conditions it can able to withstand in chemical attacks. And where we are using this carbon bricks means it is used as a materials for a construction of electrodes. That means carbon bricks are used as an electrodes in a many reactors, and also it is used as a lining of highly chemically resistant equipments, and also it is used in lining of atomic reactors, electric furnaces, heat transfer systems, copper, aluminum and lead smelting furnaces. Next we are moving to chromite bricks. Chromite bricks are also comes under neutral refractories, and the chromite bricks are mixed with little amount of clay, and then we have to fire it up to 1500 to 1700 degrees Celsius. After firing it, we have to cool slowly to get a perfect structure, that means perfect morphology of chromite bricks. Next we are moving to properties. Then the chromite bricks have high density and it is resistant to acidic as well as basic slags, and then it has moderate resistance to spalling, and it can use up to 1800 degrees Celsius, and their refractoriness under load is 1430 degrees Celsius. That means we can use this chromite refractory only at 1400 degrees Celsius when we are applying load on it. Otherwise we can use it for 1800 degrees Celsius, and it has a good crushing strength. It has a moderate thermal conductivity, but when we are comparing to carbon bricks, chromite have a lesser thermal conductivity. And next we are going to see where the chromite bricks are used. The chromite bricks are mainly important use of chromite bricks in to separating that acid and base refractory linings. That means between the acid roof of basic open hearth furnace and basic bricks of side walls. Just imagine if the roof of brick is made up by acid bricks means, then the side walls are made up by, because we are using here the side walls is manufactured by basic refractories means, then the line is separated by using this chromite refractories. So you have imagine like this. And then it is other applications of chromite bricks are, it is used in bottom of choking pits and also sodium carbonate reverberatory furnace, because sodium carbonate is basic in nature, but when we are exposing the carbonate manufacturing, when it is mixed with water means it produces carbonic acid. So the carbonic acid is acidic in nature. So both acid and basic refractories cannot be used in sodium carbonate reverberatory furnace. So there we have to use the neutral refractory such as chromite is preferred here. Next one is phosphorite bricks. So here the raw materials for phosphorite brick is peridotite, serpentine and tall. The peridotite is molecular formula of peridotite is magnesium silicate and mixed with Fe2 plus ion, and then serpentine molecular formula is magnesium 3 and Si2O5, that means hydroxides of magnesium and silicates, and then talc is hydroxides of magnesium and silicate oxides, and then the peridotite serpentine talc is mixed with magnesia with proper appropriate amount, and then we have to fire it about 1700 degree Celsius. And then when we are increasing the magnesium oxide concentration, the firing temperature is also increased. So the RUL of, that means refractive under load of phosphorite bricks also gets higher. So generally the RUL of phosphorite bricks is 1650 degrees Celsius. Next we are moving to the property of phosphorite bricks. That one is a good it has a good stability and it has a good corrosion resistance and also temperature resistance. That means it can able to use as a insulating bricks, or otherwise it has a high heat capacity, and it is strong anti-alkali slag property, and it is resistance to ion corrosion, Fe2O3 corrosion. That means if we are using pipeline and we have to build a construction or otherwise a cement constructed material or over construction material means, then where we have to prefer the phosphorite bricks. And also next we are moving to the applications of phosphorite bricks. It is mostly used in non-ferrous metal melting furnaces, linings, and also steel making flat surface of regenerator due to less corrosive in nature, that means resistant to ion corrosion, and also used in cement rotary kilns. So next we are moving to insulating refractories. That means we have to use the insulating refractories to minimize the heat loss either internally or externally. So generally the refractories of low thermal conductivities are used as heat insulators. Here the phosphorite brick we can prefer it as a insulating refractories for low operating temperature, that means below 90 degrees Celsius. We have prefer gas selgar, vermiculite, asbestos employed as a heat insulators. Then if the air is present in between the voids of refractories means it acts as a poor conductor of heat. So mostly the porous materials are preferred for insulating refractories. Alternatively, instead of getting natural or otherwise the basic materials from natural sources means we can't use it for long time, or otherwise the properties or reusability of that materials is not that much enough to compare with chemically or synthesized one. So in this manner they are preparing an alternative basic materials to manufacturing that insulating refractories. One is it is made up by either clay, grog, and then water is mixed with chemically prepared foam. That means the foam is either made up by rosin, that means 45% of rosin and 7% of caustic soda and water which is stabilized with glue and gum. Then the foam mixed with clay, grog, water is molded and then fired to prepare as a insulating refractories. So generally each and every refractories have a different applications, and based on that application or based on that area where we have to use that refractory means we need to look up the properties of that refractory, mainly that RUL, that means refractoriness under load, and then its chemical property, either it is acidic in nature, otherwise basic in nature, or otherwise neutral in nature, or otherwise it is oxidative one or reductive one. We have to check these parameters and then we have to finalize that material where we can use, then we have to finalize that material for perfect application and also long time use. Thank you.